All right. Good afternoon or good evening, wherever you are. So today we're gonna do the tutorial sheet. Um, I'm sure you guys know the tutorial sheet for today is, is this one. Um, all right. This is the tutorial sheet for today. So you have two prices that have the joint survival function given by this. The first part is to derive the distribution of the maximum of the prices. So can you take a couple of minutes and see if you can do it? And I'll show you. Just try to do the first part, which is to derive the CDF, cumulative distribution function of the maximum of the two prices. I am recording this one. So I'm sorry I forgot to record the last one, the one on Tuesday. Apologies for that. Sorry. I'm recording this session.
That's why I suspect also 一定係嘅，因為我冇喺度。
Please take a couple of minutes and see if you can do part one. There are 10 different parts.
我今日好晏先落雨啦，都 OK 咯。食晒個阿三嗰個有咩入邊？有蝦有魚，落多。啊。OK。
You guys okay? There are not so many people attending the session today. I don't know why. All right, guys. So let's see how we can. So this is you have X and Y are prices. All right. So you have the joint. So F bar. Remember, if you read the videos on week 5, you would know this is the joint survival function of X and Y, and that is equal to 1 plus X divided by A plus Y divided by B to the power minus C, where X is positive, and we are also assuming that Y is positive too. All right, so the first part of the question or the tutorial sheet is to derive the CDF of M. M is the maximum of the two prices. Remember, X and Y denote the price. Okay. So to work this out, I mean, I don't know whether you guys watched the video. I'm sorry, there was no video on Tuesday. My apologies, but I did similar questions on the week 5 video, so you might have seen that. All right. So this is the CDF of M, right? And this is the probability that the maximum of X and Y is less than or equal to M, right? Okay, and this is the same as saying that if the maximum is less than or equal to this, then X has to be less than or equal to M, and Y has to be less than or equal to M, right? So this so this is the same as the saying, by the definition of the joint CDF, what you have here is the joint CDF of X and Y at M comma N, right? So that's remember, that's the definition. If you guys looked at the videos for week 5, you would know the definition of the joint CDF is precisely this, right? Okay, now, but what we are given is not the joint CDF. What you are given is the joint survival function. So this is where you need to use one of the relationships I talked about in the week 5 videos. Now, there is a relationship that expresses the joint CDF in terms of the joint survival function, which says the following. I mean, if you have looked at the week 5 videos, you will know this is one of the relationships I mentioned in those videos, right? Okay, it's a relationship expressing the joint CDF in terms of the joint survival function. Now, each of these guys we know because that is given by this. So this is equal to 1. So this guy is just, all you have to put is M and 0 into this equation here. So you get 1 plus all right. So this is the answer to part 1 of the tutorial sheet. All right, is that clear, guys? Any questions on this? Do you have any questions you want to ask about this before I go to the next part? Hello, guys, talk to me, please. All right, thank you. Right, now question 2 or part 2 of the tutorial sheet is to find the PDF of M. So to find the PDF, all you have to do is differentiate the CDF, right? Okay, so you differentiate this with respect to M. Okay, so you will get, you should differentiate this with respect to M. You will get the following. Right. Excuse me. Excuse me. Right. So this is one more term, which is the third term will be this. Okay. So this is the PDF of the maximum of the two prices. Okay, guys. The next question on the tutorial sheet is to find the nth moment of M. Right. Now, I think I've done similar questions before. So when I say the nth moment, I mean the expected value of the nth power of M, right? That's what I mean when I say nth moment. So let me take this away. So this is part 3 of the tutorial. So here we're looking for the nth moment of M, right? So the expected value is of M raised to the power M. This is what I mean when I say the nth moment. So this would be the integral. Because you're dealing with the continuous distribution, you need to do the integration. All right, this is what you need to do, right? Now we know the density function from the previous part that we did, and you may recall that this has 3 terms. This one has 3 different terms. So you will get basically 3 different integrals to work out. So the first integral will be this is the first integral, and the second integral is this, and the third integral will be so these are, so you need to work out these 3 integrals in order to find the nth moment of M, right? So obviously, I mean, I think I mentioned this before, integration is something you learn by practice. I mean, it's not something, you cannot learn integration, you have to do it by practice. So to work out each of these integrations, obviously in this case, you will need some kind of substitution, right? And I will tell you what they are, right? For the first integral, you will need to set x is the variable I'm going to substitute for, equal to 1 plus m over a. I mean, why I'm making this substitution, I mean, I cannot explain because that's something you need to learn by practice, as I said, right? This is the substitution that will work for this one, right? And this implies that m equals to 8 times this, right? And this implies that dm by dx is equal to minus a over x squared. All right, so this will, this substitution will work for the first integral. All right, so when I so it will work for the first integral, right? And for the second integral, in the substitution that will work is the following. I'm going to again call it x. I mean, I could call it some other name, it doesn't matter. Right, so this substitution will work. This substitution here will work for the second integral, right? So let me highlight this here. Right, right. And finally, for the third integral here, for this one, the substitution that will work is the following. All right, this substitution will work for the third. So let me highlight this here. All right, and let me highlight this one. All right, and okay. So you have three different integrals. Yeah, you have these three different integrals and three different substitutions. So it's basically why the third integral do not star m to the power n. Oh, yeah. You're right. So you're right. Yeah. I left out. Oh, yeah. Thank you for pointing that out. So there should be a m to the power n here, which I forgot to put. Yeah. So there should be m to the power n here. Thank you for that. Okay. So so you have three different integrals and three different substitutions. right? And now, once you make all the substitutions and rewrite the integrals, which I'm not going to do, which I'm not going to explain here because it will take forever, right? So once you do the substitutions and rewrite the integrals, this is what you will get. You will get the following. You will get the first integral will reduced to 0 to 1 of the following. All right. So after substituting and everything, you're after doing everything, which I'm not going to explain in this video, but this is what you will get, right? And the second integral will reduce to the following. Right, and finally, the third integral will reduce to the following. All right, so these are the three things you will get after doing the substitution and simplifying things, right? Now, as you can see, each of these integrals is the same, right? So you can combine the three into one. So you can combine the three right? And okay, all right, guys. Okay, now this is where do you guys recognize this integral? This is something I talked about in one of the videos in the preliminary section. You may remember, okay, let me write this down. You may remember something called the beta function. I actually did a video on this for the preliminary section. And the beta function is defined by the following, you may recall. So if you haven't seen the video, please please do so as right whenever you have time. So this is the beta function at alpha comma beta is the integral from 0 to 1 of this multiplied by this. All right. So this is, I mean, this is the definition of beta function. And as I said, there is a video on this I did under the preliminary section. Okay. Now I'm gonna use this definition to rewrite this, because clearly this is of this form, right? So the final step is as follows. All right, so this you can rewrite by this definition as the beta function. Your alpha will be c minus n, and your beta will be n plus 1. All right, so this completes part 3 of the tutorial sheet. Now part four is asking you for the mean or the expected value of m. So to find the expected value of m, all you need to put is n equal to 1 into this equation. All right, so this will become, is easy. So it becomes c at a plus b minus ab divided by a plus b, and then the beta function at c minus 1. Okay, n plus 1 is 2. So this is the mean. Yeah, c should be greater than n. You're right, Lynn. Yeah, c. I mean, otherwise this is undefined. Yeah, c should be greater than n. You're right. Part 5 is to find the variance. Is to find the variance of the larger of the two prices. And as you know, the variance is the expected value of the square of the m minus the expected value of m power 2. Okay, right? So to find this, all you need to do is put n equal to 2 into this. And this one, we already know what it is, right? It's this one. Okay. So you guys will get the following. So this, for this one, I'm going to put n equal to 2. So this will be c a squared plus b squared minus a b over a plus b squared beta function at c minus 2 comma 3. So here once again c needs to be greater than 2, otherwise the beta function will be undefined. So c has to be greater than 2 minus the square of the expectation, which we already know. So it will be c squared right. Okay, so this completes part 5 of the tutorial sheet. Now part 6, right? Before I do that, can you take a few minutes and see if you can do part 6 by yourself? Part 6 of the tutorial. It shouldn't be difficult for you guys. So just to go back to part, I'm sure you guys know what part 6 is. Where is it? Okay, here we are. So part 6 is this one here, right? So the question is to find the CDF of the minimum of the two prices. Okay. It shouldn't be difficult for you to do. Can you take like a couple of minutes and see if you can do that? Yeah. You guys okay? Right. I know it's not difficult, but it's okay. Let me show you how to do part 6. Okay. So here the question is to find the CDF of the minimum of the two prices, which is denoted by L, right? So by definition, this is the probability that capital L is less than or equal to little l, right? And this is 1 minus the probability that capital L is greater than little l. And this is 1 minus the probability that the minimum of the two prices is greater than little l. Okay. So if the minimum is greater than, then each of these guys has to be greater than, right? So this will be 1 minus the probability that x is greater than L and y is greater than L. Right now, this is, if you look at the definition of the joint survival function in the week 5 videos, I also mentioned that in the review session on Tuesday, that this, what you have here is precisely the joint survival function of x and y at L comma L, right? Now this is given to us in the question, right? So the final answer is 1 plus L divided by A plus L divided by B to the power minus C. All right, I'm sure you got this right. So this is part 6. Part 7 of the tutorial is to find the PDF and PDF of L. So it's simply the derivative of the CDF. Right, if you differentiate this with respect to L, you will get the following. Okay, so this is the PDF of the minimum of the two prices. And part 8 is to find the nth moment of L. So I'm going to do something similar to what I did earlier. So the nth Yeah. So this is going to be the expected value of L power n, which is the integral from 0 to infinity of L power n times the density function. Unlike before, the density has only one term, so it's easier to work with, right? Now, if you sub this into this, you will get the following. All right, so this will be 0 to infinity of L power n 1 plus L divided by A plus L divided by B to the power minus C minus 1 dl. Okay. All right. Now to do this integration, obviously you need a substitution that will work, right? And given the experience you already have with the previous parts, you should know the substitution that should work, right? So what I'm going to do is I'm going to set x, you can call it whatever you like, x equal to all right, this is the I'm going to make this as the substitution. So that means your L is going to be sorry, excuse me. All right. All right, times 1 minus x divided by x, right? And this implies that dl by dx is equal to minus of ab divided by a plus b times x squared. All right, so this is let me put this in a box. So this is the substitution I'm making, and I'm gonna do the substitution into this, right? All right, guys. Now, if you do the substitution and simplify things, after a while, I'm not going to show you the details, but I'm sure you know how to do it. So after doing the substitution, you will get the following: C all right, this is what you will get. Now, once again, this integral here must be familiar to you. It's the beta function, right? So this is the beta function at your alpha will be c minus n, and your beta will be n plus 1. Once again, c must be greater than n, otherwise this is undefined. All right. So this completes part 8 of the tutorial. Part 9 is to find the expected value of the small of the two prices. So you put n equal to 1 into this, all right? So you will get right. So that's part 9. And finally, the variance. So part 10 is to find the variance of the small of the two prices, which, as you know, can be written as this, right? Now to find this, you put n equal to 2 into this, right? And this one we already know what it is, right? So here you must have c greater than 2, otherwise it's undefined. Okay, so this is the second moment minus square of the first moment, which is right. Okay, guys. So this is the variance of the L. All right. And any questions on this, guys? Hello, guys. You okay with this, or you have? Okay. Now, all right. Thank you, guys. Thank you, Patrick. If you have any other question, just feel free to contact me 24/7. And also, yesterday I sent an email about the in-class test. Is that okay with you guys? The in-class test will be on the 15th of December from 4 to 4:30, right? And you should do the test wherever you are, and you should send me your scanned copy of your answers by email as usual, but the email should reach me before 4:45 p.m. right? So I will not accept any emails after that time, right? And the test will be closed book, but I mean you should. I hope you understand. You don't. You know. You should just use your only papers, pens, and pencil, and you should not access computers or anything except for reading the question. You shouldn't access any websites or anything like that, right, while doing the test. Okay. All right, guys. Any questions on that, guys? Are you okay? All right. So if you have any questions, yes, you have a question, Yubi. Yeah, please tell me what the question is. Is that Yubi? Yeah. After finishing the test, you can use your phone to scan your answers. Yes, you can do that. Yeah, I mean, what I meant is that during the test, you shouldn't use any of the technologies. But after finishing the test, you can scan your thing using whatever technology you have and email it to me to reach me before 4:45 p.m. UK time. on 15 December. Okay. All right, guys. I hope that is clear to you guys. Any other questions, guys? So the test will account for 10% of the mark, as you know, and I will mark the test on the same day. And so you will know your mark before midnight on the 15th of December. That is UK time. So you will know what you got on the same day as the test. All right, guys, just feel free if you have any questions. Just feel free to call me or email me or Zoom me 24/7. I'm here to help you guys. Okay. All right. Have a good day. I'll talk to you later. Okay.